Welcome back, ladies and gentlemen. The goal of this video is to be able to find the vertices and the foci of an ellipse and go ahead and truly try to write it in its standard equation for an ellipse. And so let's dive into this one. 4x squared plus 9 squared equals 36. The question that I first have is, what is the goal when you are finding the focus, the vertices, and just the standard form of an equation of ellipse? There is a certain part of the standard form that is critical to understand. Well, that's that the right side of an ellipse has to be equal to 1. And so that's kind of our first instinct to see what we can do, is to go ahead and get that right side of an ellipse set equal to 1. So let's take a look. So if I go ahead and take 4x squared plus 9y squared equals 36 and divide through by 36, that will get our right side equal to 1. So 4 goes into 4 once, into 36 9 times. 9 goes into 9 once, into 36 4 times. So x squared over 9 plus y squared over 4 equals 1. Okay, so at this point, the question is it a horizontal or a vertically represented ellipse? Well, the only way we can identify that is based on the numbers in the denominators, because the number that is greater is from the major axis. And if from the major axis, it will tell us if it is horizontal or vertical based on if it's under the x or if it's the denominator of the y. And so since the greater number 9 is underneath the x, that means it's going to be represented horizontally in this particular case, all right, in this particular case. And so let's really see what we're looking at here. So I'm going to kind of draw a quick representation of this. So we know we're centered at the origin because it's just x minus 0 and y minus 0. So it's centered at the origin. And then we want to kind of think, all right, well, what do we know? Well, we know that distance of quote-unquote a, little lowercase a. If you remember correctly from the previous video, the distance of quote-unquote lowercase a is the distance from the center to the vertex. And so if this 9 is a squared, well, that means that a was 3. So the distance from the center to the vertex is a distance of 3. So that means that this vertex is going to be at 3, 0. And then you'll have another one over here at negative 3, 0. Well, similarly, this guy is the minor axis, that's semi-minor. And so if this guy is b squared, that means that b was 2. And so that means down here, I will have a negative or a 0, negative 2, and a 0, positive 2 for on our minor axis there. Now this really kind of helps us out because then we can go ahead and ultimately determine what the focus is going to be. And so you can kind of start to see where this ellipse is going to end up coming from. Well, I'm going to throw a couple of points just in here for some relation right now. Let's say that here's our focus point, and here is a focus point. So what we need to understand is that we have somewhat of, if you will call, a Pythagorean relationship at this point. So if you remember, the distance from the center to the focus, we denote it as lowercase c. And then the distance from the center to the vertex was lowercase a, and the distance from here was lowercase b, from the center to the minor axis there. And so then what we can end up doing is ultimately kind of coming up with a Pythagorean identity for an ellipse. Because what ends up being true is that this same lowercase a actually is the same distance from C to F. And this allows us to understand that this guy is also a. So we get a squared is equal to b squared plus c squared. Now, I know this is kind of confusing because you're so used to a squared plus b squared equals c squared from a Pythagorean theorem. But remember, we're using lowercase a, b, and c for a little bit more of a different aspect in this case. We're kind of labeling things different. So this Pythagorean identity will help us identify what the distance from the center to the focus is going to ultimately be. And so if that's the case, I can see here that a squared is 9. It will equal 4 plus c squared. So c squared will equal 9 minus 4, which is 5. If I square root both sides, I get c is equal to plus or minus the square root of 5. So what this tells me is that c is square root of 5 to the right of the center and square root of 5 to the left of the center. And so that means that one focus point is going to be at square root of 5, 0. And then the other focus point is going to be at negative square root of 5, 0. Because it's, of course, away from the origin at 0, 0. And then let's kind of just clean things up and identify everything that we wanted to know. The vertex was at negative 3, 0 and at 3, 0. And these four answers would ultimately be